All right, you guys. Today we're going to talk about flooding. And in your lab book, this is Lab 5, actually 5.1. I think 5.2 has you out in the field, trumping around in the stream. No, actually 5.2 has you dropping sand down a tube. But one of these does. 5.3 has you out in the field, maybe. But so today we're going to talk about something that's a real, actual thing that geologists, hydrogeologists, geologists in charge of water and water-related incidents, actually do and actually work with on any given day. And you're going to make a tool in the end that is, again, a real thing and actually something quite helpful and useful. In Utica here, one of the issues we've been having with flooding is Sequoia Creek, okay? And for whatever reason, when I moved here 20-some years ago, I chose the Mohawk River, okay, for grabbing the data from. It occurs to me that we might actually see a little much cooler data, much more applicable data, especially for those of you that live around here, if they have these gauging stations that we're going to talk about along the Sequoia. And I'm not sure if they do. I'm going to have to look into that. But for now, we're going to study the Mohawk, which if you spend any time driving up and down the thruway or living around it, you know that it is fairly heavily controlled. All right. They lower the water in the winter. They let it go in the summer. And you see a lot of variability. Again, if you've ever bothered to look out the window when you're driving down 90. This is still real data, but it is heavily humanly meddled with. Okay, which is another reason I'd like to mess with Sequoia maybe and see what's going on there. So, as you read in your lab book, and again, if you haven't yet, please, you folks at home, please read 69, 70, 71, 72, 73, a lot of reading today, and 74, okay? All the way over on 74 is a picture of a kiosk-looking thing. It's got some solar panel and a little satellite-looking thing. Over the years, of course, technology just keeps getting smaller. And this is a picture. Yeah, I took this one. This is over by Harbor Freight down Commercial Drive. Okay, they have a gauging station there. The Sequoia is actually called the Muddy over there for some reason. As far as I could tell, it's a Sangdang stream, but when it goes through Whitesboro and whatnot over there, they call it the Muddy. But this is over there. And this is really small. Most of them are going to look like little sheds next to a river. If you, again, drive down 90, you'll see a handful of these here and there. There's one by Little Falls, all right, which is where some of our data is actually coming from today. There's one near Delta Dam, which is where the rest of our data is coming from. And like I said, usually these are much bigger units because, tech used to be a lot bigger. They essentially consist of a bobber, a paddle wheel, and something to log the data. The bobber tells us how high the water level is, and the paddle wheel helps them gauge how much water is flowing through there. Okay? And that is gauge height, the bobber, how high it is, and discharge, the flow. They record a whole bunch of other stuff, but those are the two things that we're looking for. They get temperature, probably pH, all the stuff that they'd talk about in an environmental science class, perhaps. So, as this is about flooding, all right, we cut straight to the chase, and the folks at the USGS, that stands for U.S. Geological Survey, cut straight to the chase if you go to the right page on their website. And what they gathered was the peak discharge at any given station for every year. In other words, for this year, what was the highest that river got? And when you're talking about floods, of course, that's what you want, right? And then what we use that for we look at a number of years, put that all together. We make a nice little graph out of it, and then we're able to make predictions. Now, when I started doing this 20 years ago, we didn't have, we had 20 years less data, of course, and making a 100-year prediction was a lot more of a prediction. Now, we're 20 years later. This data starts in 1928, I think, and we find ourselves 4 years from having 100 years worth of data instead of 25 years or so of having 100 years worth of data. Your 100-year flood would be presumably a little more accurate of a guess. All right. You could go all the way out and make a guesstimate for a 500-year flood. Now, again, on 95 years worth of data, do you want to go and speculate about a 500-year flood? Well, you could. I wouldn't necessarily make too many bets on it, but you could. But that's the idea. We make a tool, we use it to figure out how likely any given area is to receive a flood of a certain level. And we'll tell you all about that as we go through it. Don't worry. So that's the idea of what you're doing today. So your lab book directs you to this website. All right. And there used to be 2 versions of this lab. And in fact, that still exists in here. The old school method in quotes. I've never recommended that anyone do it that way. But some people used to be so afraid of Excel, which is what I'm going to talk about. But please feel free to insert, what does Google call it? Sheets. Okay, Google Sheets, Apple numbers. It doesn't matter. I'm just going to call it Excel. A lot more people used to be that was such a foreign thing to them than it is now. You guys, for better or for worse, are getting more of that crap in high school. Especially the Google Docs stuff, okay? And I assume they have you doing more than just going to the writing part. You have used the numbers and so on and so forth. But you guys, generally speaking, are way more tech savvy than the students 20 years ago, okay? So the old school method exists. Pen, paper, calculator, and a whole lot of time. I'm not even going to mention that today, okay? Because I want you guys to do it this way, because the graph you still have to do on pen and paper. All right. Yes, Excel makes graphs, but not this kind. You'd have to go into a statistics program, and then again, we jump way back down the learning curve there for most of you. Because even in stats, I don't think you guys are using. Anybody taking stats? Do they have you guys using software? Yeah. So there's programs out there like Minitab and a handful of other things that would do this for us, but please, again, repeat, do not make your graph in Excel. You have to hand draw this sucker. And as I just said, there's 80 points roughly per site. So that's 160 dots. You guys want to save as much time as you can, so that's why I'm teaching you Excel here. All right, so anyhow, lest I digress. So this is the gauging station, that one of the 2 choices here on the on page 70, top of page 70 there. And this is the Delta Dam one, obviously. And again, peak stream flow. What is the highest stream flow during any given year? And you see this wonderful graph here, and it looks like it is a scattered mess. And it really actually kind of is. Now part of that is the scale. All right. If you remember anything about graphing, how close these are has a lot to do with how spread out these are, right? This is years. We can't really do anything about that. But this here, that's going to tell you how spread out this stuff is. So that's one of the things that's going to get messed with as we go through here. The other thing is, and this is why you can't use Excel to graph, is we're going to use a totally different kind of graph paper than you guys have ever seen. It's kind of like Semilog, but it's not. All right. Anywho, so this isn't horribly helpful. What your book asks you to do is go up here and click on Table. And I'm going to go to Table for a moment just because it is still very nice and pretty. So it splits up the data starting, as I said, 1928, going all the way down through 22. All right, it doesn't have 1923. It doesn't have 2023 in here yet. That'll be there soon. All right, so you guys have to go from 1928 to 2022. And as I said, you're looking at, that's more like 90 points. But, okay. So, as you read in the book, one of the first things you need to do is sort these from highest to lowest. Or is it lowest to highest? You guys tell me. You just read it. Highest to lowest. Right. All right. So this is where old school really stinks. You literally have to go through here and say, okay, highest stream flow is, okay, there. And you put a 1 next to it. Then you look for the second highest. And we used to do this in class. And we'd get about 20 minutes in, and then I'd start hearing the swears come out. Because what happened, you guys missed one. Okay? You have to erase all the god-dang numbers, go back, start over again. Can it be done? Yes. Should it be done? Not in this day and age. So what I have you guys do is, and again, this is all in your book, highlight, however you highlight on a Mac. I'm clicking, holding, and pulling down. And I'm stopping right there. All right, I just highlighted all that data. I go up here. Now this is off the recording screen. I went up to edit, and I'm hitting copy. Opening Excel, which I should have done already. I apologize. And I'm hitting, well, now your lab book says pay special, so let's just do that. There's some hypertext in there. Some of that stuff was blue and underlined, right? You don't want that. So you would click on text, paste, and voila, there's your data. Let's make this big enough so people can actually see it. There's one huge problem, and this is where this new step is really, really great. See all these superscripts over here? I don't know, again, if you could see it real well, but those little 6s everywhere, and occasionally there's a 2 as well. Where's the 2's at? 2's up here. A 2 and a 6. Well, copy and paste gets really confused, and it puts in that 6. And you're like, okay, I know how to use Excel. I'm just going to tell this column to be this column minus 6 and fill down and everything's great. No. Because it actually, you have to get rid of an entire power of 10 there. If you take 6 out of this, it just turns it into 19,400, not 19,406. And it's actually 1,940. So you have to subtract 6, divide by 10. Again, it could be done, and we used to have to do it. The easier thing that we used to do was just put the clicker up here, delete, enter. Delete, 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 enter. Delete, enter, delete, enter. Okay? Again, wasn't horrible. It was better than doing it by hand. However, now there is this wonderful tab separated option. Nowhere near as pretty and kind of scary looking, to be honest. But it gets rid of the 6th problem. So instead, I'm going to have you guys go to tab separated. And this is the first thing I want you to make changes in your lab book, where it says to go to, where does it say to do this? Somewhere on page 70. All right, maybe instead of scratching it out for the time being, just write, oh no, you know what? I did a weird thing here. I explained it one way. The procedures actually starts right here on 71, how to import data into Excel. All right, right there you're going to want to say tab separated instead of table. See where it says table? Scratch out table and write tab separated. Everything else stays the same for the moment, so we're going to copy, we're going to paste. I'm just going to open a new sheet in Excel. If Excel listens to me, why won't you let me put a new sheet in? There we go. And this time, I think plain old-fashioned paste works. Yeah, it does. All right. Now, again, let's make it big enough that people can actually see it. For you folks at home, it might get too big. I apologize, but I got people to see the screen here. All right. So what do we need? We need, nope, we still got to do paste special. Still got to do paste special. Because it pasted everything into one text. Sorry, I just learned about this on Monday. So paste special. Must be some hypertext hidden in there somewhere, even though it's tab separated. It really shouldn't be. All right, now everything's in its own column, okay? So we don't need USGS. We don't need the code. We want the year. Don't get rid of the year. So I'm going to highlight these first two. Delete. Boom. This is date. This is apparently empty. We're going to get rid of the empty one. And see, look, all those 6s went into their own column. And we say goodbye, 6s. And then we could get rid of all this other stuff. So you're going to leave the numbers here and these smaller numbers here where everything's filled in. And you're going to leave the date. Because this is missing one thing. And this is why tab separated still isn't awesome. But we want to insert a row here. Again, this is off the screen for the recorder. I apologize. I'm up to Microsoft Excel bar, insert, row, and I just put a row there. So this is date. This is flow. Well, actually, we called it discharge. Huh? Let's call it discharge. And this is gauge height. All right, you don't believe me? Let's go all the way back here. And actually, let's look at it on the prettier thing. Table is still prettier. So, April 8th, 1928, 6.9, and 2,930. All right, same data. Make sure you have the right data. Now, the only thing is it's in a slightly different order. Not a hugest deal. I'm so used to doing it the other way. I'm going to move this stuff so it goes date, gauge height, discharge, like the instructions do. All right. If you don't know what I just did, basically it's copy and paste. I know how to move columns, but again, your comfort level will vary. I understand that. You guys are welcome to team up on this, okay? I know, again, not everybody, even now, not everybody is totally cool with this software, but please don't just do it by yourself and then share it with your lab mates. If you're going to share data, have them sit with you, kind of what I'm doing, talk through it so they actually learn a little something, all right? All right, now it gets funky, and now it gets really great. So what does your lab book ask you to do? Again, what it wants you to do is sort these by order, all right? Again, we're on 71 here, blah, 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 blah. There were superscripts. We got rid of that. All right, we're down at the last bullet here. Once your data is sort, oh, no, we got to sort. All right, so let's do the sort. So everything is highlighted here. You're going to go over to Data, Sort. My list has headers. My list has headers because I typed them in. Date, gauge height, and discharge. I recommend you do that. All right, if for whatever reason you don't, your list will not have headers. You would uncheck that. You want to sort by, what do we want? Date, gauge height, discharge. What are we sorting by? You guys remember? The flow, the discharge, okay? So we want to sort by discharge, and we want smallest to largest or largest to smallest? We want the biggest one first. We want the biggest one first, so largest to smallest. Sorry, those are loaded questions when they're yes, no's like that. And boom. Again, could you have done that by hand? Yeah. But now if you're unsure of your excelling, you're not sure how much you excel, so to speak, take a couple minutes and eyeball it. Make sure that it actually does start with the highest discharge, goes down to the lowest discharge. All right. You can't really screw this up if you hit the right buttons, but every so often you might not grab everything, like you might have forgot to grab the date column or something like that. So always go back, keep the website open and just spot check. Okay, I've got the highest date in 1945. Let's scroll to 1945. Here it is. We had a discharge of 2,506, and oh my gosh, that's not what we have. Here's one other problem. Water year, you see this right here? It's kind of like the school year. It spans 2 years. Like this school year is 23-24, right? This is the water year. They only grab the first date. So sometimes what happens is that you have two peak discharges in different water years, but the same calendar year. So what I'm talking about here is, let's go to 1945, and let's see, it is right here. See, 1945, October 2nd, 1945, September 30th. Very close to one another. Big storm, apparently. But one of those fell within the, actually, they're not very close because one fell within the 1946 water year and one fell within the 1945 water year. Perhaps that's a typo. We don't know, but it's their data, so we're not going to mess with it. But so actually you did have 1945, October 2nd, 8,560 as your highest one. Where's this one at? 1945, September 30th. Wrong button. 2560. Scroll down to our 2000s, 2560. There it is, September 30th, 1945. So the sort is good. Okay, the sort is good. So we told you to make this column, I believe it was M. Let's look. We're in the last bullet now. Once the data is sorted, create a column next to stream flow named M and another named R. So there's our M. Here's our R. So M is just, and this is where I've got this stuff spread out. I thought it was easier to explain things, like define things first. So page 69 and 70 gives you all your definitions, and then the procedures on 71. That's kind of annoying, as I see we're actually using that here. So M is the stream's rank, okay? Why they used M instead of R for rank? Well, that's because we used R for something called recurrence interval. Anywho, stream is rank, or M is rank. So this is the highest one, so it's 1. This is the next highest one. It's 2, 3, 4, 5, 6, 7, 8. You could do it by hand, or you could grab one, go down, and going up to edit, fill. Now, if you just do fill down, you're going to just copy those 9s or whatever number we left at. All right? You don't want to do that. You want series, and it'll count for you. If you wanted it to count by 2s or 5s or 10s, you would change this number right here. But we want it to count by 1 because we're trying to count like normal people. Don't touch anything else. All right, just make sure that says a step value of 1, and voila. All the way down through 95. Now, again, for some of you, it may take less time to just type in all those numbers. Feel free, okay? But if you could learn some neat little tricks here in how to use Excel, so on and so forth, not a bad thing. All right, I like to keep everything nice and centered. It's all those years of doing gradebook in Excel. Next is R. R, as you see on page 70, is n plus 1 divided by m. All right, well, that's annoying. What does that mean? Well, N is the number of years on record. Number of years on record, we just counted. It is 95. 95 plus 1 is 96. And we're dividing it by M, which is this column here. Now, when you're doing a formula in Excel, you always start with the equal sign. And what number did we just say M was? 90, or N plus 1, 96. 96 divided by, now, you could just type in the number 1 here. And then the next time you'd have to type in the number 2, and then the number 3, and then the number 4. But here's another cool little trick. If you click on the cell instead, and we do that fill down again, it's smart enough to know that the next time you want it to use the 2 for the calculation, the next time you want it to use the 3, 4, the 5, so on and so forth. So we're going to click on the cell instead of putting a 1 in there. So you guys know 96 divided by 1 is 96. We're going to do a fill down real quick here. You're not using series now. We just want to do a fill down. And again, this is all in the lab book, and I'm recording it. This is why I'm recording it. So you know darn well 96 divided by 2 is 48. 96 divided by 3, you can think about for half a second. Hopefully you'd come up with 32. Again, check your math. Even though Excel did it for you, make sure it makes sense. We're going to cut these down to 2 decimal places, just because you can't graph out that far, even if you wanted to. So that's under Format. I apologize, you folks at home can't see the top bar here, but I just clicked on Format, Cells, Number, decimal places is set at 2, that's fine. And again, we're doing this with the whole column highlighted, so it changes all of the data for us. I like everything centered. I also like my top line in bold, so you know it's special and separate. All right, we just did about 2 hours worth of work if you do it by hand. And what also stinks is you have to do this again for the other gauging station at Little Falls. Please take a little time, find a friend, a parent, whomever, that knows how to do Excel if you don't. Google Sheets, again, whatever. It's really helpful. All right, I'm not even going to ask, are there any questions? Because I'm sure I've seen you guys blinking at me. There's lots of questions. Watch the video again. Read the book to the extent that it is helpful. But this is the general idea of what you need to make. I would go so far, just again, in case you forget, this is delta. All right, because you're going to be making 2 sheets. You want to remember which data is which. If you double click on the tab, it allows you to change the name so it doesn't say sheet 1, sheet 2, sheet 3 anymore. The website where you get Little Falls at is also in your book at the top of page 70, all right, which is where you get the Delta Dam one. Yeah, you could probably Google your way to this stuff, but just type it in, okay? Type it in. Now, the graph paper. So, this is your special paper, and I didn't know, I did this lab actually before I taught here, and I found it somewhere, adapted it to fit us and our needs and our local streams, so on and so forth. But they always use this kind of paper about it, and being, you know, not the math person that I'm not, I didn't pay a whole hell of a lot of attention to the graph paper. I looked at it quickly. You guys know log paper, semi-log, and good old regular graph paper, right? Those are the 3 types you've probably encountered by now. Regular graph paper is just that. All the squares are the same size, up and down. Log paper varies, in both directions, I think, okay? Sometimes it's wider apart, sometimes it's narrower together. Semi-log, vertically, it looks just, where's my mouse? Vertically, it looks just like this. It's evenly paced, but horizontally, I don't use X and Y. Horizontally, it varies. So I just assumed this was semi-log paper. And way back when, I went next door to my office mate who was a math teacher. I said, hey, man, I need a piece of semi-log paper. He's like, why? What are you doing? You're a geologist. You guys don't do math. Blah, blah, teasing me. And they're right. We don't do math. And I'm like, no, I got to do this. And he's looking at it. And he's like, that's not semi-log paper. I said, what do you mean? He's like, it doesn't cycle. I said, what do you mean it doesn't cycle? He said, well, it gets bigger and then smaller, and then it starts over again. He says, there's a pattern to it. He says, this doesn't cycle. So it took us a while to figure it out. This is something called probability paper. All right. And again, that's sort of what we started this whole conversation talking about. How likely are you to get such and such flood, right? So probability paper sounds like a great thing. I just didn't know it existed. I think he even had to look it up. My point being, please make a copy or 3 of page 77 in your lab book, because I doubt you're going to go to graphpaper.com and find a sheet of this stuff. All right? It only exists in some weird little corner of the geologic world. Maybe other places. They might use it in cosmology for all I know. I have no idea. But it's not out there freely. Okay? And you don't want this as a crummy scan. You don't want this copy. So do what you can. Use your phone. Make a good copy. Apple nowadays, if you open up a notepad, it'll actually make a PDF scan for you. It's really amazing if you hold it still enough. You could just take a picture, okay? Like it was 2015 or something like that. But do what you got to do. Make some copies of this. All right. So we are concerned with 2 columns here. The vertical axis and the horizontal axis. Vertical column is stage height. You're like, wait a minute, we didn't use that word yet. I know. Why on their website they say gauge height, and why on their graph paper they say stage height, I have no idea. Stage is gauge. They rhyme. At least that helps. Okay? So this is gauge height. Which again is why when you do your sort, you want to make sure you bring everything with you. Next is the R value, the recurrence interval. So if you go back and you look at your data sheet, I guess we'll scooch it this way. And actually, I suppose these are calculations at this point. This, by the way, serves the purpose of a lab report. This is our lab report in air quotes for this semester. You used data, you manipulated data, you created a graph. You will create a graph. You're doing everything you need to do, and you're going to answer questions based upon that graph. So I think this is a little more fun than all that writing you usually have to do, even if there is math involved. Then you usually have to do, like, say, if you're in environmental or chem or physics or something like that. So not a whole lot of writing, but you do got some mathing to do. Anywho, what do you need off of this? You need 2 columns. You need your gauge height, and you need your recurrence interval. So it's literally just like any other time you've plotted a dot. You're going to look for 96, and you're going to look for 11. Please don't worry about these decimal points. I'll show you in a minute. So 96 and 11. Let me try to zoom this a little bit. Can't get it on the screen, but you want to be able to see stuff. So again, this is really wonky paper. Starts with 1.01. Doesn't start at 0. Doesn't even start at 1. Starts at 1.01. 1.05. 1.25. 2. 2.5. 3.3. Okay, see what I mean? Anywho, what do we want? 96? So, you have a 50 and a 100. You have, let's see, let's try going by 10. 60, 70, 80, 90, 100. This one happens to go by tens. You got to count. 96 is going to be somewhere in the middle of that. And who remembers what we wanted? Was it 11 or 15? 11. All right. Now, 10 and 20, what do we got in between it? Let's try twos. 10, 12, 14, 16, 12. Nope, that doesn't work. How about if this is 10 and that's 15? What does that make this? 12.5 and 17.5. Annoying, but it is what it is. So you would find wherever 11 is. You go up to 11, you're over at 96, and what do? Let me get a tool here. We found freeform the other day. Huh, it's not here today. I was able to draw with just a pencil. Where'd it go? There was like a squiggle button somewhere. No. All right. Well, it's not showing up for whatever reason. So I can't draw a little dot. But you would draw a little dot at 96 and 11. Okay? Then you move down to the next point, which is 48 and 11. Then 32 and 24 and so on and so forth. Okay? 95 times. Sorry. Now, a couple tips. And please don't follow these rules in math class. I really wish I could draw on this thing. I don't know why I can't. You're going to get a whole bunch of, maybe it's because I'm zoomed. That shouldn't matter. Ah. Give me a second. It was really... because the ovals and the stars and everything were just way too big to make a dot with. Yeah, and I don't want a line either. Ah, but that brought up squiggle. Beautiful. Boom. I don't know why that worked. So where were we? 96 and 11. Let's make it bigger so you can see it again. You guys even see those dots? Kind of. All right. So my point is, let's just make a bunch. I'm not going to do all 95. By the way, it slopes from the upper right down to the lower left. Okay, just as an FYI. You're going to do this lightly in pencil. That way you could go over it with a highlighter. Remember when you used to make graphs? And then you're going to make a little square over to the side that says yellow highlighter equals delta dam. You color in a little square. And then use a pink highlighter or orange or whatever you have for another color for your other points. That way you could tell your points apart from one another. So, all right, I've just drawn a whole bunch of points here. Here's where I don't want you stressing out. Your math teacher is going to make you obviously put it in the exact right spot. We're going to put what's called a best fit line through here. All right? A best fit line is a straight line that more or less represents your data. If there was a math requirement for this class, you would be plotting a regression. Okay? We were not, because there is no math requirements for this class. Excuse me. That's stats. All right. You're going to take your ruler after you've put these points in here, and you're going to lay it down literally on the piece of paper and try and center it through this cluster of points. Again, sloping, so it's the upper left to the lower right. And you're going to draw a line through the data. You're not connecting the dots. It doesn't look like a stock ticker or an EKG. No, 1 straight line through the data. which if I dared to switch modes, I could probably draw a line, but I don't want to lose my scribbly pencil. So, back to my point. Do you think it matters with that vague general line that you're drawing, whether this dot right here is right here or over here? Not really. Okay? So please don't pull your hair out or whatever, go crazy trying to find the exact right spot. Please be as accurate as you can, but don't freak out over it. Okay? Some of you will, some of you are inclined to, some of you are not inclined to. So I'm talking to those of you that would stress about something like this. Yes, in math class you would want to be as accurate as possible. In here, it doesn't really matter whether that point I just drew goes there or, well, that's a little high, but you get my point, okay? And again, you're drawing 95 of these things. You're going to have a general, let's just get gutsy here. Oh, we're still in freehand mode. Oh, boom. Let's change the color. I know that's a thing. Okay, let's undo that. Well, we won't change the color. This is kind of what your best fit line would look like, okay? Based on the data I drew. And you're also going to want to bring it farther than your data. This is that tool we talked about in the very beginning. Based on this 95 years worth of data, you're drawing this trend line, this average line. I could now ask you, what is the expected value of a 500-year flood at Delta Dam? How do you figure that out? You go over here to 500, you go up to your line, you go over to 17, no, this one's 15 in this case. You go over to this number right here, that's your answer. What is the expected value of a 50-year flood? You go to the year 50, you go up to your line, and this is where it gets hard. Use your ruler here to just kind of like lay it straight so you don't lose it going all the way across. And it is 16, whatever the number happens to be. So all of this work to make this piece of graph paper to answer the questions on page 79. When you turn this in, you're turning in two things. You're turning in this graph, page 77, and you're turning in the questions, page 79. You can't answer 79 without doing 77, and you can't do 77 without doing all that stuff before it. I don't need to see all your stuff before it, because I could tell by looking at your graph if you did the sort right. If you did the sort wrong, the line's going to go from the upper left to the lower right. If you didn't sort it at all, you're not going to be able to draw a line through it because it's going to be all over the place, and so on and so forth. So you don't need to print that stuff out. You don't need to turn it into me. If you need to print it out to help yourself think and to work through it, by all means, do it, okay? But you don't need to turn it in. So here's the next part. As I said, you go through and you do Little Falls next. I picked this data specifically because it was far enough apart. Little Falls is going to plot up here. I want you to put both sets of data on the same graph. That way you can compare and contrast it. It's going to ask you the same questions for both sites. All right? So it's going to ask you the same questions for both sites, and it's a lot easier to compare those sites if they're on the same piece of graph paper. Yeah, you could do it on two separate ones, hold them up against a window and peek through. Use onion skin. There's a lot of things you can do. But I cherry-picked, and I know it'll fit. It's going to have the same slope, okay? So you're going to have the same thing going on up here as you had down here. You're going to choose your colors. Again, pick two highlighters. Delta Dam's one color dots. Little Falls is another colored dots. Your line may as well be pencil colored, but feel free to be artistic. I don't care. Put your little key off to the side. Delta Dam is this color. Little Falls is that color. Questions? It's a lot of work. I won't kid you. It is a lot of work. But the mainly in drawing the dots. If you can get Excel to work for you, if you know how to use Excel, so on and so forth. All right. Well, you might not have questions now, but unless you walk out the door and start this right now, you're probably going to forget a lot of stuff. This will be on your class site. You folks at home, this, of course, will be in your lab folder. I can't emphasize enough the importance of using pencil on page 77 until you know that you're correct, and then go over it with your highlighter. Even still, you made that backup copy of page 77, so you'll be okay if you do screw it up somehow. The only thing I haven't really talked about is what this recurrence interval means. We've all heard 100-year flood, 50-year flood, 500-year flood. What does it actually mean? It doesn't mean you get one every 100 years or every 50 years or whatever. What it actually means, and that's where the top of this paper actually says, all right, is what your likelihood of getting this year, that amount of water in any given year. So a 50-year flood, means every year you have a 1 in 50 chance of getting water that high. A 100-year flood, you have a 1 in 100 chance of getting water that high any given year. So they just call it a 100-year flood 50 because you get one about every 100 years. Well, we all have played Monopoly or some such game, and you roll a 1 3 times in a row. It happens. You're not supposed to, right? You have a 1 in 6 chance every time you roll that dice of getting any one of those numbers. And some of you maybe could calculate the likelihood of rolling 3 1s in a row. It's not very likely. But again, you know you've done it or you've seen somebody do it. It's the same exact thing. You could have a 500-year flood 2 years in a row. Statistically, you shouldn't, but you could. So that's all it means, okay? It's the likelihood, or as they say up here, the percent probability. And I know these numbers don't match up with exactly what I said, but if you do the math, they do. You have to convert a little bit. It's much easier to understand as a 1 in 100 chance any year of getting it. It's kind of like a raffle ticket. So that's what these mean. And like I said, this is a real tool. Let's say you want to build a new subdivision near the Mohawk River, all right? And you know that the flood heights are going to be 10 foot, and you've got your topo maps. You guys have already worked with topo maps. You can say, okay, I need to go 10 foot above the stream banks, and that is our 100-year flood mark. Please don't build your subdivision within, that range. And in fact, if you want to be really smart, you'd back it up another 10 or 20 feet from that value, because there is that 500-year level. So it's a real tool for real things. And yeah, at that level, they probably have software to do all of this nowadays, but it wasn't that long ago that some intern was doing it by hand. Okay. And then handing it to the boss to go out and say, yeah, based on our data and our calculations, blah, 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 blah. So, we good? All right. Hit stop on the recorder. You folks at home, again, please communicate with me if you have any questions, any problems. Email me, ask questions.